wonder what this instruction does. This is how you look like when you trying to learn second language. It's all the same shit. Okay, so, but I don't know what is STP. So this one is interesting. So I suppose registers are just like X's, right? So you have X0, X1, X2, and they're general purpose registers. Okay, that's understandable. So there's also SP, and I suspect that SP is a stack pointer. That makes sense, right? So because in x86-64, there is RSP. What's interesting is that you also do this thing. You're probably subtracting 16 bytes from SP, effectively allocating some memory. And this is probably what it does. So I'm not really sure what is STP, but it accepts 3 arguments in here. So what I suspect it is doing, right, so it's probably 3 address code. It's a 3 address code. So it probably takes an operands from second and third address and then kind of saves it into this one, right? Because then it uses this one, x22, to save it into SP, which, by the way, tells me that the order of the arguments is here, like for move, is probably this is the destination and this is the source. Right, but in here it's kind of weird in a sense. It's kind of weird in a sense, so I'm not really sure. Maybe this is some sort of like subtract or something. I'm not 100% sure. I'm not 100% sure. So this is probably some sort of a prelude, right? So this is some sort of a prelude. So yeah, I do not fully understand this one. So this is add. And it's definitely you adding some stuff to x0, right? You definitely adding some stuff to x0, and then you do puts. So then you kind of recover the stack, I suppose, and then you sort of return. Okay. Do not fully understand everything, but it's I suppose it's kind of workable. I suppose it is kind of workable. So the thing is, I don't know a single ARM assembly that is kind of similar to FASM. Do I really have to use x86-64 Scheisse? What do you guys think? Do I have to use x86-64 Scheisse? Oh, like GCC Scheisse, that's what I mean. Do I really have to use GCC to program in ARM? Yeah, so this is what I said. This is what I thought, right? So I probably have to use, GNU assembly. Does FASM support ARM syntax? FASM is a little bit complicated. Okay, so FASM is a little bit complicated in the sense that FASM, the first version, so you know what I'm talking about. FASM first version was purely x86-64 assembly. Then Tomasz Grichter, the creator of FASM, created the second version of FASM, which is actually built on top of FASM-G. Right, and FASM-G is sort of like an engine for creating assemblers. So essentially, it's a meta language that lets you create different architectures as libraries. So that's the thing. Right, and the idea was that x86-64 is going to be one library, ARM is going to be another one, and so on and so forth. But as far as I know, FASM-G is not that actively used, right? So it's just like, I don't know how well it is supported and how well it is going to work and stuff like that. And I feel like if I'm going to start using this kind of thing on a stream, it's going to be a huge rabbit hole, which I'm never going to be recovering from. So yeah, I don't know. Doesn't ARM make their own assembler? Maybe, but I mean, we can just use GAS, right? So just like a GNU assembler and stuff like that. All right. Anyway, so let me think. So ARM Linux GNU as hello world example. Just a simple example, I think, is going to help us, right? So there's an ARM developer, so this is an official ARM, and they have a hello world example. I hope I'm not banned on their website. Yeah, I'm probably banned. Fuck. Oh, on x86. Okay. ARM.com. Hello world tutorial on x86-64. Are you sure that you're ARM.com? Okay, so I'm banned. My IP is banned in there, so whatever. Okay, so hello world in ARM assembly. All right, so this is gas syntax. This is gas syntax. Okay. All right. Assembling. So this is ARM, Linux, Android. Let me see. Do I have as? I do. Right. So, and by the way, I think I need to install man. Let's install man. You don't have man. What the fuck, man? Man, what the fuck? Grep man. Oh, it's a man pages. Okay. Probably have to do man pages. Alright. So it also probably makes sense to install maybe development pages. If I do man as man wait Brovskis. I should have actually done grep man. So man pages. I probably have to install man doc, don't I? Right, so that's what I have to do. Install man doc. Freaking, why didn't I call it install? Because like I have a reflex. There's also mandb, but I mean I didn't see mandb honestly. So okay, there we go. So as So what's funny is that there was also dev. So maybe we need to have devil. Wait, I remember grep man. What was that? Man pages POSIX. So yeah. Man pages POSIX. But I'm not sure if it's going to work, honestly. Nah, doesn't do that. But I mean, you can always do something like help. Yeah. That's one way to do that. That's one way to do that. Bin utils doc. Well, we can try to do that. APK list grep bin utils. Yeah, there is a bin utils doc. Look at that. So, and let's just do add. It works. Look at that. Thank you. It's kind of weird. Like, I mean, I would expect that corresponding main pages are installed by. Well, I mean, it's a pretty common thing to put documentation in a separate package. I don't know what I'm talking about. Anyways, so maybe we should follow this sort of tutorial, right? Does it sound like a good idea? Sounds like a good idea. I think we should try to do that. So, do we have just a Vim? APK list grep Vim. Do we have Vim? Yeah, we do have Vim. Because I want to have a little bit of a syntax highlighting, you know? Just a little bit of a syntax highlighting. I'm going to do add Vim. And let's freaking go. Main.c. What? Excuse me? Is this really? So, I didn't expect that, honestly. And it also does some color scheme. Okay, color scheme. So there's not that. It's absolutely freaking broken, by the way. It's just like I think it identified the terminal incorrectly. So the terminal, I have to set the terminal in a particular fashion. Yeah, so that's something. So term x something. So we can try to. I can't even copy paste it. I'm trying to copy paste this specific message because I think it is saying incorrect. Chat, stop moving. Chat, shut up. Okay, I'm trying to. Yeah, there we go. All right. Thank you so much. So can I do something like Vim? Oh fuck. All right, we're not gonna have Vim then. We're not gonna have Vim. So chat is useless as usual. So I suppose we're gonna be using VI without any syntax highlighting. Oh, somebody made a mistake. Well, it's on you. That's why I don't listen to chat, because you're debating me all the time. No, we're not gonna have any syntax highlighting. It's all on you. It's all on you. Anyways, right, so we're gonna do main.s, and maybe I'm gonna actually split this entire thing like a little bit. And I suppose we need to have an entry point. So this is the entry point, right? And I'm gonna just leave it as it is, right? So maybe I'm gonna do return. There we go. So how do I assemble this entire thing? I can try to do main.s, and did it create anything? Okay, apparently it maybe did, but I have too many things in here. Okay, so I want to create like a hello, and I'm gonna move this thing to hello, right? So then I'm gonna remove main and a out, so that's pretty cool. And I'm gonna create like hello asm, move main.s, hello, hello asm. Let's go there. Cool. So if I try to do something like this, it created a.out. It created a.out. What is this file? What is this file? It's yeah, it's a LSB relocatable. I suppose what we should have done, we should have actually maybe outputted main.o. Right, so, and this is what we've got in here. And after that, I suppose we have to link it. Right, so here is assembling. Right, so you kind of creating an O, and then we're using linker in here. We're using linker. And by the way, it uses flag S. I'm not really sure what the fuck is that flag, but maybe it is needed or not. And okay. Omit all symbol information from the output file. Why would you use that? Like, I mean, I don't think it's necessary in here. So we're gonna be just using LDO and whatever. Okay, LDO main.o. Cannot find symbol underscore start, and this is exactly what I expected. This is exactly what I expected. So what we have to do in here, we have to mark it as global, right? So because here, as you can see, we have to mark it as global. You have to spell it like this. There we go. So, you know, we probably have to install make, right? So apk install make. I think with the make it would be reflexes, man. I can't help myself. Why APK developers didn't create an alias for install? Like, I know that it's add, but I mean, in majority of the package managers, it is install. You want to have add, keep add. But if you just edit an alias, that would have been such a good, like, quality of life improvement. It's kind of weird, right, that they didn't do that, but I mean, okay. Add. I mean, I understand that add is shorter, right? So, but anyway. Okay, let's create a make file. By the way, I think I need to remove Vim. We don't need Vim anymore. Fuck Vim. We're gonna use VI. We're gonna use VI, the most base text editor. So I want to create main. It depends on main O, and in here we just do LD main O. That's what we're doing in here. Okay, so to create main O, we depend on main S, and we use as O main S. Right. So and then we do something like this. Boom, we created an executable. Look at that. It seg faults. It does in fact seg fault. Why does it seg fault? Because we literally don't do shit. We just return. I suspect this is literally the same situation as with x86-64, right? So you have nowhere to return. To end the execution of the program, you have to call the exit syscall, right? Exit syscall. So let's actually see how you do that. So to call a syscall, you use the instruction SVI with a 0 operand, because I suspect that dollar is literal, it's immediate literal, right? It's not any register or anything like that, because registers are usually the percents, right? So it's immediate literal. It would be kind of cool to have a reference guide for all of the ARM instructions. So let's actually put this thing in here. Right, so because this is the hello world that we're going through. So ARM SVI instruction. So what is this instruction? So SVI, and I don't have an access to developer arm.com because it is banned in Russia, because Russians may accidentally access it and learn how to use this dangerous technology and use it against the civilized world. So that's why it is banned in Russia, even though I can probably get it by using VPN, but I can't really stream with VPN right now. So maybe I should have actually, you know, yeah, we can use a Wayback Machine, right? So Wayback Machine. Russia uses ARM for missile law. So as you can see, banning, you know, ARM.com in Russia actually helps it not use it. So as you can see, it actually works. The problem is actually solved. So anyways, can can we just access this kind of thing? All right, so not available. So it was never actually saved. Can I just save it in the Wayback Machine? Okay. So we have to sign in to actually do that. So there's a PDF. I didn't want to open PDFs, but I mean, we can try to do that. Okay, so thank you so much. SVI. Software interrupt. Okay, this one is interesting. Ah, I see. So that's what it is. It's a software interrupt. It's kind of a similar to int instruction in x86-64. And as far as I know, for syscalls, interrupt instruction in x86 is still used for 32 bits. So it is still used for 32 bits. Isn't that PDF for 32-bit ARM? So that means in 64-bit ARM, it is not a software interrupt, but it's something else. Right. I mean, okay, so it's a wrong one, but does it mean that SVI in 64 bits is something else? I didn't think so. It kind of makes sense that it's still software interrupt regardless of the bits. So on x86-64, this is what is used for syscall. So it's kind of similar in here. So there's also SVC. Very interesting. So SVC, what is that? There is no SVC. Okay. I don't see the SVC. Well, I mean, they kind of mention it, but there's no information about that. Okay, so we know that it's a software interrupt, at least, right? So we know that it's a software interrupt, and it's probably just a syscall. So here we set up a status, right? So we have to set up the status. So we move. Well, I probably have to do something like R0. Right, R0, and then we put immediate value of 0 in here, and that is the status. Let's actually put 69 in here to confirm, right, that this is how you control the exit code. All right. So then in R7, I suppose we put the number of the syscall, right? So this is the number of the syscall, and it's going to be 1, right? Okay. So can I actually run external commands from here? Okay, I can actually do that. That's pretty cool. Expected a register or register list and operand move. It didn't work. That is fascinating. So is that because I have to SVI 0? So I have to do something like that. So it's 3. It didn't like something about move. It's for 32. Ooh, yeah, it's a 32. Fuck, this is a wrong guide. This is actually a wrong guide. So this is Android NDK. So that means we'll have to find something else. So ARM ARCH64. But I mean, we kind of close, I think. Okay, so there is a similar guide for ARM64. Okay, that's pretty cool. Yeah, and it's it's SVC, right? So it's SVC, and I think somebody actually gave a link in here, right? So yeah, so let's actually put all of those things into the description, right? So this is that one, and also here is the SVC guide, right? And there was also a PDF somewhere that we use. I think all of that has to be in the references. So here is the PDF. Right, because all of that was helpful. I'm trying to capture everything that was helpful throughout this journey. Right, so all of that was helpful. So, and since this is 32 bits, so this is 32 bits like this, and this is 64 bits, and this is where we have this thing. So supervisor call causes an exception to be supervisor call. This is such a fascinating concept. Supervisor call. This looks so fucking cool. A supervisor call is a hardware instruction used by Interesting. So I suppose System 360 by IBM was also using kind of the same terminology, right? So, but I mean, I suppose we're talking about ARM. I can't really access ARM.com, but I mean, it's kind of interesting. So, instruction generates SVC. A typical use for SVC is to request privileged operations or access to system resources from an operating system. Okay, so it's kind of similar to how x86-64 works. Right, so originally in x86 in 32-bit mode, you used interrupts to ask operating system do something, and then in 64-bit versions, they introduced syscall instruction. It's kind of similar in ARM. So ARM kind of mirrors x86. So why? So far, ARM just feels like a different flavor of x86. I thought it's going to be like completely kind of different, but it's just a different flavor of x86. Is that true? Like again, I never had experience with ARM before this stream, like a real experience with ARM. So it just like feels like a different flavor of the same shit. So the current instruction. Only so many ways to make a useful CPU. True. That sounds fair. So more like Intel 64 takes all the lessons from ARM. Oh, okay. Okay. So parallel code is more perilous. I don't know what that word means. I'm sorry. Anyways, so let's continue. Like we need to get to the point of hello world, right? So if we achieve hello world today, I'm gonna call it absolute tsoding moment. So let's freaking go. We have to move, so we have to use X. And what's interesting is that they're using like a different flavor of assembly as well, right? So you just do X, and then we're saving. So immediate values, they now have a completely different syntax. So they use hashes and stuff. Okay, so then we use a register. Well, in here, by the way, we probably want to put 69, right? So this is a 69. So then in here, we just do 93, and this is probably the syscall, the exit syscall, which is a rather big number for a syscall, honestly, which is a rather big number, and it's actually a supervisor call. Okay, let me try to call an external command, and it worked. So, and now let's exit. And if I try to do that, it doesn't segfault. Remember it segfaulted before? It doesn't segfault. And now if I take a look, what is the exit code of the previous command? It is in fact 69. Absolute tsoding. We can control exit code. We can control exit code. We can change it to something else. Right, so we can do main S. Right, and now I can do maybe 32. Right. Make run echo 32. Look at that. We can control exit code. So that's pretty cool. So what's the next thing? I suppose we want to actually put like a 0 in here. So that's totally fine. So the next thing is write syscall. Write syscall. This is rather cool. So the arguments are for the syscalls are literally x0, x1, x2. And then the code for the syscall is just W8. I would like to know what kind of registers do I have in ARM. Let me close everything that is irrelevant to what I'm doing. arch64 registers. Okay. So there's in Russian, so I'm gonna open this one. So this one is also closed. arch registers and instructions quick start. So general, holy 31. So refer to generally to use registers. Then another 31 x64 bit wide access same registers. Oh shit. Bro, wait a fucking second. This is so fucking awesome. I can port ports on ARM and I can use general purpose registers as the stack, as a limited size stack. Right, so essentially, since I know the size of, in ports, there is one interesting thing about ports is that I always know the size of the stack at compile time. I always know the size of the stack at compile time. So that means at compile time, I can treat access as basically like a stack like this, right? And essentially say, right, okay, so I pushed two numbers, they're stored in x1 and x0, and that's basically the top of the stack, right? I can just basically treat it as an array, right? And it's where I store the stack. So, and it's automatically all of the registers. CPU pipelining is gonna go crazy, is it? So it's too bad for CPU pipelining. You can't index the register. I can at compile time. That's the thing. I can index them if I know the size of the stack at compile time. Right. Because I know how many of them is stored at compile time. So I can do that. I didn't see any problems with that. This is actually kind of cool. And this is something that I did with the Beam virtual machine, because Beam virtual machine has thousands general purpose instructions. Maybe, by the way, if I learn the second, platform, ARM platform, I may have enough inspiration to recover port series to port ports to ARM, because why not? Why not? So sounds like fun, right? So we'll see how it goes. We'll see how it goes. But anyways, so that's a lot of registers, and yeah, so it's a pretty good platform. I mean, it's 2025. We have to have a lot of registers, right? So we can afford a lot of registers. Honestly, we can just afford that. Stop being poor. Give me thousands of registers. Just give me thousands of registers. Anyways. So this is a move, and in here I'm just moving the standard input, right? So this is the number of the standard input. LDR is a sus instruction. What the fuck is LDR? I suppose it, LD probably stands for load. R probably stands for register. Or address, or it's probably, yeah, it's probably load into the register, address into the register, so that's what it is. Because essentially what we have in here is, yeah, so it's basically the message where we store all of that stuff. And also, but why do we use this kind of thing in here? I'm not quite sure, because is that loading an address or loading a value? I need to read the definition of this instruction. So let me see. So LDR, can I do something like that? So LDR, immediate. Aha, there's 3 flavors of LDR. It stands for load registers, but you can load immediate value, you can load literal, or you can load register. So there's 3 variants of this thing. Okay, that's pretty interesting. A load register immediate loads a word or double word from memory and writes it to a register. So you can load it from memory. Okay. So literal calculates an address from PC, program counter or something like that, value, and immediate offset loads. So yeah, it's kind of like, it's the same instruction, but it's used for kind of different situations. But anyways, you get an idea. I get an idea. So, and I suppose if we want to just do x1 message, we have to have that message defined somewhere. Right, so here is the message. And here we say that it's an ASCII, hello, arch64. And we also put n in here. What's funny is that we don't put null terminator. This is because it's right, it operates on the size of the of this thing. So, and I suppose then we compute the length. Dot probably means the current address minus the address of the message, and equals probably means that it's sort of some macro, right? So it's sort of some macro. Okay. So, and then what we're doing here is LDR x2 equal len. And I suspect that these two instructions are actually different flavors of LDR. That's the thing. Even though it looks like it's the same instruction, it feels like the same instruction, even syntactically, it's actually two different instructions. Because here, we're loading the address of the memory. We're loading the address of the memory. Yeah, I think dot, my hypothesis is that a dot is the same as the dollar, because otherwise it doesn't make any sense, right? So this is my hypothesis. Right, so here we're loading an address of the message, but len is a length which is a single immediate value. So this one is loading address into the register, and this one is loading immediate value into the register. This is actually two different instructions. This is my hypothesis. I hope I actually understand correctly. Obj dump it back after compiling. That's a good idea. That's a good idea. So we're gonna obj back and just see, because obj dump shows you the sequence of bytes, right? It shows the sequence of bytes. We can actually confirm that it's two different instructions. All right. So then here we now specify the number of the syscall, right? So it's gonna be 64, and then we just do supervised call, which is 0. Okay. So can I now compile this entire thing? It compiles, and now. If I do something like absolute tsoding, we achieved hello world on ARch 64. Absolute fucking tsoding. That's actually cool. That wasn't that hard, honestly. That wasn't that hard. So yeah, I have a playground for ARM development. That's so fucking cool. And what's funny is that this is do I have LDD? So this is not a dynamic program. Well, so if I just do something like file, it's statically linked. Can I run it on my mobile phone? Can I ADB shell into my mobile phone, upload this executable there and run it? And it will say hello from ARM64, if it's 64, right? But I don't know if it's 64 actually. But I don't know if I'll be able to write into its file system. If the syscall numbers are compatible. That's a good point. We don't know if it's compatible. There's only one way to know. Okay, so first of all, we wanted to do obj dump. Babaji dump. All right. Look, it supports callers. Like, it's just Vim couldn't properly recognize shit or anything. Anyways, so so main and stuff. Where is the? Oh, it's a start. Okay. It's all still relative. Look at that. It's kind of the same, honestly. It's kind of the same. But I mean, maybe they are the same, actually. Maybe they are the same. Kind of hard to tell. Kind of hard to tell. So, and it's all relative. So here is the message, and it's just a bunch of words. It doesn't really tell us. And it's also relative load. Look at that. Wait, does equal create a value in static memory? I feel like it does. Doesn't make any sense to me, honestly. Okay, so here is the message, and it ends with 0A, so this is a new line, and our hello world also ends with new line, right? So this is how we know that that message thingy is actually, like, doesn't have anything after it. Okay, so 64, this is a 4 bytes value, and then we get 88. So then, so it's a start plus 28. So did it put it somewhere in a different place? 10. It's 16, right? So I'm pretty sure it's 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It created a value. It created a 32-bit value in in the code itself and it loaded it from a pointer. Here it is. Here's that motherfucking value. I thought it's immediately loaded. Because it loads this thing, right? So it's B0. Here is the 400B0. So here it is. Here they are. And it load. But then it's an address, isn't it? Right, because it doesn't load it by value. It doesn't read it. It loads address. Does that mean that this syscall accepts the size of the buffer by address? Like, why does it store address in there? Can anybody tell me? Because if it doesn't store address, that means what this operation did is read just this thing, first 4 bytes of the message, and it doesn't make any sense. That means it accepts it by an address. What the fuck? So we can try to do the thing that the chat says, just use, move, right? So we can do move directly just to test things. How do I comment out? Okay, so I can probably use the this thing. Okay, so this is move x2. Let's do 16 directly. Can I put 16 directly in here? Right, so I can do something like that. Okay, so obj dump. So, and as you can see in here, so there was 3 words in here before. Since we removed that length, that word does not exist there anymore. And here into x2, we're directly loading 16. Let's see if it's going to work. It still works. So I'm not sure how LDR works, because in first case, it loaded the address where the buffer starts, and in the second case, it read the value from the memory by that address. So it's basically Leo. I suppose it is kind of like Leo, but it's just like I do not fully understand how it works. It's kind of bizarre. It's kind of bizarre. So that also probably means I can try to do move xmcg. All right, so let's give it a try. So it's something like this. So move x1 mcg. Can I do something like that? I can, and it doesn't print anything. So if I do babaji dump, it just puts 0 in there, by the way. It just puts 0. So, but that probably means that what I have to do, I have to prefix it with equals. So let's rebuild. Bad expression at operand. Okay, don't really know what's up with all of that. So I suppose it's better not to question this for now, and just like let it do it like this. Just let it do it like this. Okay, so we'll get this stuff. So this hello from AArch64. So I wonder if I can download this entire thing. How can I SSH into this system? let me think. So first of all, let's power off it. Let's power off it. Cool. Now, how much time do we have? Well, we'll already spend 2 hours, so everything goes according to the schedule. So what we want to do is sort of like a forward the ports. So this is how I did that in here. So this is how I forwarded the ports. We're going to put this in here. And so here is the netdef user net0, and I also specified this device as a net0. Right, let me put that stuff in here. I wonder if this is going to work. So this is the 2 new lines that I added in here. I'm going to try to run it. Seems to be working. So I'm going to wait until it loads up, and then I'm going to try to maybe SSH into it. So, and it's supposed to use like user at localhost, blah, blah, blah. Okay, so it's just sort of like tunnels the port. It just tunnels the port. So if I'll be able to SSH into that, that will be actually super cool. That means I can SCP that main out of the virtual machine. So it's loading up. It's loading up. Crony D. So SSH probably root at localhost at that specific port, and the port that we specified is this one. Fuck, doesn't work. Can't really do that. Can't really do that. SCP mine streamer at. You think it has to be 10.2.2, not. We can try to do something like that. It doesn't work that easily, fortunately. Can't access it. Can't access it. Even though, like, I set it so it can access these things, maybe I just like run it incorrectly, did I? Is a host IP from ADB. We're not doing ADB, people! Jesus Christ! Okay, bonding. So let's power off. We're not doing ADB yet. For fuck's sake. So run is... So did I specify it? I feel like I might have not I did specify it. Look at that. I did in fact specify it. So and then I just do that. It's is that something with the wrong networking device? Is that not supposed to be E100 or something? Is the OpenSSH installed? Yes, it is, but maybe it's not running. That's the thing. All right, so let's try to do that one more time. That's actually fun. It's really fun. Just explore ARM and stuff. Is the port mapping direction correct? It should be, because I used these scripts before. And I just copy pasted from x86-64. I think it's correct. It might be not it might be that SSHD is not running. So that could be the case. Did anybody see here in the logs? Did it start SSHD? Maybe it didn't. Okay, so root bonding. So can I do SSH? It is running, actually. It is running. Maybe it has something to do with IP link. So SSH root at 10.0.0.22. Yeah, so it's 2. And then permission denied though. It might be, it might be, what is it? The host, right? So 2.2 might be the host. So, and the actual thing in here was IP address, SSH root at 10.0.2.15. Yeah, name, well, I mean space. Yeah, bonding. And I basically connected to itself through SSH. All right, so that's really interesting. That's really interesting. So I connect to itself, but I can't still properly access it. All right, so if I do SSH localhost root at maybe 270.0.1, because maybe it just like, you know, resolves into something weird. That could be the case, actually. So localhost might be on my machine resolving to something weird. Still can't access it. Right, so, and the documentation says that I have to do localhost. And none of that stuff, like 10.0.2.15, none of that works. Definitely, none of that works. That doesn't work. And that doesn't work. God damn it. God freaking damn it. So I'm not sure how to, like, what exactly to do. So let me see, run SH, people are, this is exactly what I'm doing in here, by the way, right? So people saying different things. Right, but that's literally what I'm doing here. So here's the net stuff. Remove nick user. You mean this thing? Okay. So I wanna, that's a good point actually. I didn't think about that. Virch.io, but is it going to break something? Maybe actually, might actually break something. Let's power off it. Why is the device net zero? I have no idea. That's how it's documented. Alright. Okay, it's doing things, I suppose. Nick user. All right. Ethoslab. I don't know what you guys are talking about. Okay. So SSH, let's prepare for this one. So we're just waiting until it loads up. I started to use Wirsh. I don't know what is Wirsh. Holy shit, it works. Okay. Bonding. Yo! We SSH'd into that motherfucker. By the way, maybe since we're over SSH, it will be able to properly identify the, what is it called? The terminal and stuff like that. So let's do apk add vim. Right. So I'm over SSH right now. So this is not a direct console, just over SSH. And I have callers finally. So I can now hello vim main.c caller scheme desert. Okay, so I can even have a decent caller scheme on ARM. Finally, freaking finally. So that's pretty cool. If I go hello Azim vim, thank you so much by the way for suggesting to remove dash nick and stuff like that. Look at that. Finally, what about caller desert? Yeah, boy. Finally. So this is so cool. I now can just run this virtual machine on my other machine, so QEMA doesn't consume all of the resources as I'm streaming. Right, and I can SSH into that machine and have like a proper experience and stuff like that. vimrc, yeah, I need to do vimrc. So it's just like vimrc. And I probably have to like enable some other stuff. So caller scheme desert. Right, and then I can do something like that. And it's automatically like this. See, I know how to use Vim. This is so cool. I really like that. But anyways, so we can now do something like SCP. Right, and might as well move the stuff in here. We going into home, so that means it's a hello Azam main. Bonding. Okay. We get the file. Oh, look how small. It's 1 kilobyte file. It's a 1 kilobyte file. What the fuck? By the way, what kind of ARM is usually used on mobile phones? ARM 32 or ARM 64 on the modern ones? Because I'm not sure like which one do I have. Might not actually work. Both simultaneously. Now ARM 64. I actually have like a cheap ass Xiaomi, or Xiaomi, how to pronounce it, and I think I want to actually try to do something with it. Depends. I see. So 64 on my favorite laptop. Okay. So if I take a look at this thing, so 64 LSB LDD, not a dynamic executable. Should I try it? Xiaomi 7 is ARM version 7.1. I don't remember which one I have. I think I have a box somewhere. Let me see. Just a second. I don't actually use it, by the way. Oh. Is it share? No, it's something else actually. Yeah, it's a Redmi Note 13. It's this one. So I'm not sure which one is that. Like, I don't actually use it. I just like bought it and put it aside because I wanted to switch to it at some point, but I didn't have time. So it's kind of hard to tell. So we can give it a try. It's a ARM version 8. So it's actually 32 bits, right? So it's not 64, unfortunately. It's actually not 64. Can we build for 32 bits though? I wonder. That's my carbon phone. Yeah. Just a second. Okay. Oh, it is 64. Holy shit. Okay, let's fucking go. Is it alive? Is it alive? All right. So it's loading up. It's loading up. It's doing things. It's a little bit dusty. So it has its own like variation of Android or something like that. Which I don't really remember how it's called. So it's something like Hyper OS or whatever. It's just like, I don't know. What is Redmi? Yeah, so it's a Xiaomi Hyper OS or whatever. So it's probably a modified version of Android. Of some sort. Of some sort. Why you have Wi-Fi modem on the floor? Because why not? It's a Chinese Xiaomi sub-brand. It's even sub-brand. Damn. All right. So let me see. So a lot of things. Okay, do I have... I don't have a spare USB port for this motherfucker. Okay. I'm gonna try to connect through that. So I'm gonna allow debugger working. USB debugging is on. How do I connect to ADB shell? Oh, I did that. All right. that was quick, right? So because I keep forgetting how to do that, and it's just like it's as easy as ADB shell. All right. So and yeah, so I have that, and I have everything. I don't have like CC or anything. So I wonder how to upload a file. So ADB help, ADB push. So can I do help? Because I want to read. So there's a push command. Okay. So push files that are newer on the host than the device. All right. Okay. So ADB push main, and push requires source and destination arguments, but I don't. Do I have to do something like this? Main. Yeah, so the file system is read-only. I feel like I won't be... Oh, so there is a place where I can put things. Data local TMP, thank you. So I haven't done any like mobile development for quite some time. I don't remember some of the details. Okay, this is cool. So ADB shell data local I can't tab autocomplete. All right. So holy shit! It works. I don't have compiler on my machine, on my phone. I don't have a compiler on my phone, but I can craft an executable in an ARM virtual machine, push it on my phone, and still run it. This is so fucking cool, because when I bought this phone and was actually playing with it, I was just thinking, okay, I can IDB shell into it, but I can't program in C on that phone. Right, I can't program in C on that phone. Now I can. I can simply craft an executable in a virtual ARM machine, then put it there, and it works. I can do anything in here. I can work directly with syscalls and stuff like that. This is so fucking cool. Holy shit. Like, I've never been so excited for a long time. Now package this into a PK and install. Yeah. So, but I mean, so I won't be able to do graphical things, I think. I won't be able to do graphical things because what Android has in terms of graphics, it's not X, right? It's not X, it's something else. So I need to be able to kind of connect to that graphical thing. Right, and this is where all of their Android like bullshit layer kind of comes in and does all of that for you. It will be kind of interesting to explore that. Yeah, to mesh Magicon. Yeah. Rayleap supports Android. But if you want to do like a Rayleap Android stuff, you're not doing what we are doing. You're probably doing through NDK and stuff like that. Listen, chat. We created... This is very important. This is very important. We created an executable that just ran natively on my actual hardware phone without Android SDK. Without Android SDK. This is what makes it so fucking cool and so fucking excited. We didn't use any fucking sync Android SDK. We compiled it with GCC inside of a QEMU virtual machine. This is so freaking cool. Right, so bare metal, yeah, so just like we didn't have to use their bullshit platform SDK or anything like that, and it just worked. Static linking, and we also statically linked all of that stuff. So yeah, that's so freaking cool. But I mean, it was all created with assembly directly. If I try to do C, I won't be able to use it because it doesn't have the same libc. The same libc is simply not going to work there. Though we can actually test it out. Do we have enough time? I think we have a little bit of time to explore this, because I think we can easily streamline this entire process, right? Can't we? So let me actually put all of that stuff a little bit more convenient for me. Right, so I can SSH into here. All right, so, and for example, here is the hello, right? So here is the main.c. And if I try to compile it with GCC, this is not a static executable, right? So it depends on libc, musl, arch, blah, 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 blah. So maybe it makes sense for me to call it something different, right? So this is hello c musl, like this. So this is what it is. So the reason why I do it like that, because now I'm trying to get it out of here. So this is just hello c musl. Right, so bonding. And now, so here is an executable. It's a little bit bigger, but it also depends on musl. Not a dynamic executable, but this is because it just literally didn't recognize it. Yeah, so it's dynamically linked. So then I can do adb push, and we're going to be pushing this thing into here, right? So adb shell. I'm inside of my phone, right? So I go into data local TMP, like so. And here it is. This is on my phone. This file is on my phone. I can try to run it, and I can't do that, right? So because it doesn't have that musl, right? So I can do this kind of trick with static, but with C, I'll probably have to link it with static. Let's give it a try. Right, so let's actually give it a try. I wonder if I can... Okay, so I have a little bit of a weird splitting in here. So here's the virtual machine running. Let me create another window. I'm going to do SSH. Right, so this is bonding. And so where is this thing? So GCCO, let's do static. All right, so if I take a look at the main cmusl, it is static executable, not a valid thing. It works. So now in here, I can do SCP. I can just load it in here. Then I can do push. That should replace it. Shell. Can I? Oh, that's very... Okay, that's... I don't know how to do that. Local TMP. Absolute trading. Absolute trading. You know what that means, chat? You know what that means? I can now write more complex applications in C. What if I write something more complex? What if I write Fibonacci number generator? So something like this. So while A is less than, I don't know, 1 million, right? So in here, what we're going to be doing, we're going to be printing the number like so. Then we're going to create C, which is A plus B. B is going to become C and A is going to become B. All right, so then I'm going to do GCC. So we didn't, yeah, so we need to fix that super quick. It's going to be A. So GCC. So just a second. Here it is. Main C musl. Here's the Fibonacci number generator. Cool. Now in here, I'm gonna basically SCP the whole thing. Then push ADB shell data local TMP. Can I do something like that? Yeah, I generated Fibonacci numbers on my phone. So that's pretty cool. I can now load my phone with something like I can crunch some numbers on this thing, right? So here's the thing, I can use it for crunching numbers. So that's pretty cool. That's actually super cool that I can just like use it for crunching numbers and stuff like that. So this ain't Fibonacci though. Yeah, that's weird. That looked kind of weird. What is it? Wait a freaking second. So did I do a fucky wacky? Ooh, that could be the. Actually, I did fucky wacky. So A plus B. Yeah. So I did a fucky wacky. Right. So this is becomes that. GCC. Where's the static? Now that looks like yeah. Wait. Yeah, this is Fibonacci. Yeah, 1, 2. There we go. So now, can I maybe do something like this? Can I what is it? SCP, boom, bonding, then push, boom, then I can close it, and in here. Now that's Fibonacci, right? So now I can officially say that I computed a Fibonacci sequence on my phone. So I officially freaking did that. Absolute trading, absolute trading. Okay, I've got some notification. Oh, it's Xi Jinping saying that I should not hack his phone. Oh, okay. I'm sorry, Mr. Xi. I'm not going to do that anymore. All right. So, and we're already finishing this stream anyway. So that's pretty cool. That's pretty cool. So thank you everyone who subscribed. We have a lot of new subscribers. Mr. Foss, thank you so much with the message Tsoding poking. Prada Veal, thank you so much with the prime. Pre-recorded thoughts, thank you so much. Ali Mark 71 with the message. It would be interesting to imagine you on a Swift Docs workshop. I don't know what it is, but I mean, I don't usually go on any conventions or event or anything like that. I'm pretty asocial person. Thanks Zero, thank you so much for tier 1, and AA709, thank you so much with Twitch Prime. This was actually super cool. I didn't really expect to have so much fun, like tinkering with this entire stuff. We had a lot of troubles, but we together, as a community, managed to overcome all of this trouble. So it was a sort of like a collaborative effort. Sometimes chat is very noisy and very useful, but sometimes someone just says something useful, and that's why occasionally I look into the chat, and I really appreciate you occasional people who help me with random bits and stuff like that. So yeah, that was cool. That's it for today. So we're gonna explore this kind of stuff even further. The whole point was to have some sort of an ARM setup. Right, so now we have an ARM setup. Now we can do a lot of cool things with ARM. And on top of like having a virtual machine, we have an actual ARM64 hardware that we can test all of that stuff on without any emulations or anything like that. Actual cool shit. Okay, that's it for today. Thanks everyone who's watching right now. Really appreciate that. Have a good one, and I see you all on the next recreation programming session with a Mr. Azozin. I love you. Mwah.